Okay, so welcome to our second video on measurement perimeter. So in this example, in this video, I beg your pardon, we're going to look at a few more slightly more complicated examples for us to have a go at. So the first example we're going to look at is this shape here. And this is actually a rectangle connected to half a circle. So let's just make that a little bit clearer by drawing a dotted line down there, like that. So there's our rectangle, and there's our half circle. So we want to work out the perimeter of this shape. Now the perimeter of this shape is the distance around the outside like this. So it's that distance there. So if I told you, for example, that maybe this section from here to here, let's say that that's 18 meters. And let's say that from here to here is 14 meters. How could we work out the perimeter of this shape? Well, the first thing we need to hopefully see is that if this side here is 18, then, and I'll just make that clearer by using those strokes, then this side is also going to be 18. So both those sides are 18. And this is a rectangle, remember? So if this side here is 14, then this side here, this blue side, that distance there is going to be 14. But remember, that's not part of the outside of the shape. But this distance is going to be important when it comes to the circle. So we'll just put that distance in there like that, 14. That distance there is 14. So if we want to work out the perimeter of this shape, as we have in the past, we find a starting point on a corner, or convenient point, say here, and we then walk around the outside of our shape and then add up all the sides together. So it'll be 14, and then walking down here, we need to add 18. Now I'll change colour here because we don't know this part. We don't know that distance, so we need to walk around here, and we need to add that distance as well. Once we've worked it out, we'll come back to blue, and we need to add that distance as well. So the perimeter of this shape is going to be 14 plus 18 plus some unknown amount here in orange plus 18 again. So what we have to do is work out the orange bit, because we know the other three sides, we don't know the orange bit. Now if you remember from our previous video, this is half of the circumference of a circle. This is half a circle. And so if we remember from our previous video also, that if we work out the circumference of this pretend full circle, so I'll just make it a little bit more obvious by drawing it in like that. So imagine there's a full circle there. If we worked out the circumference of that full circle and then halved it, that would give us the distance of just half the circle, which is the orange part, which is the part that we want. So we're going to work out the circumference of that full circle and then divide the answer by 2 to give us this part here. So the orange section, and we'll call it C. We'll call it A, I think. Okay, so that distance there is A. That's the unknown distance we're trying to work out. So let's work out the circumference of the full circle first. So the circumference of our circle. Now remember, the circumference is the full distance around a full circle. So the circumference of our circle, which is this circle here, the full circle, is going to equal 2 times pi times r. this distance that we want, A, is going to be half of that. So it's going to be whatever we get here with the answer divided by 2. So if we work this out and divide the answer by 2, that will give us the distance A. So let's work it out. So the circumference is going to be 2 times 3.14, that's the value of pi, times the radius. Well, what's the radius? Remember, the radius is from the centre to the edge. That distance there is the radius. Now we know from there to there, that diameter is 14. So the diameter of our circle is 14. So our radius must be half of that. So our radius must be 7. So I'm going to times that by 7. That's the radius. So if we work that out, so we've got 2 times 3.14 times 7, and that equals 43.96. So that's 43.96 as the full circumference of our circle. But we only want half of that. So we're going to divide that by 2. So distance A is going to equal 43.96, which was the circumference of the full circle, divided by 2. So we're going to divide that by 2. And in doing so, the answer is going to be 21.98. So that equals 21.98. So we now know that this orange distance is 21.98. Meters, by the way, because everything else is in meters, so we're going to make that meters. So now we can work out the perimeter. So the perimeter is going to equal, and I'll just write it up here, perimeter is going to equal, starting from here, 14 plus 18 plus 21.96 plus 18 again. I'm running out of room, sorry, so I have to go down here. Plus 18 again. And if we add all those up, we're going to get 71.96. I probably could have done that in my head, but I was feeling a bit lazy. So 71.96. And these distances are all in meters, so it's going to be in meters. So the perimeter of our shape around the outside of our shape here is 71.96 meters. Okay, our next example. By the way, pause that and copy that down pause it if you wish. Make sure it's copied down into your maths book. Moving on to our next example. We're going to make an oval. Now, I've got 2 circles here, and the reason why I haven't actually finished this is I want you to see how we build this. So these are 2 circles that are the same, and I'm going to link them up to make sort of like a running track oval, or the outside of a running track. So we'll draw a line from there to there. Oops, wrong colour. From there to there, and I'll move my ruler down so it's also linking them from there to there. And I'm going to now erase this bit in here. And this bit in here. Oops, be careful. And so what we've got is like the outside of a running track. So what we're going to do, we're going to see if we can work out the perimeter of this shape. So I'm going to put in a few numbers. So let's say that from there to there, that's that straight section. Let's say that's 50 meters. And let's put a little stroke there and a little stroke there to show that they're the same. Now the other thing I'm going to put in is the radius of this circle. So I'm going to draw a dot in the center. Now this one, remember these circles are the same, so I'll put a dot there as well, and I'll mark that distance as the radius of the circle, and that equals will be 20 meters. We'll make that. Yep. So R is 20 meters. We have to find the perimeter of this shape. So remember, once again, to find the perimeter, you find a starting point, any point, a nice convenient point, maybe the beginning here, and you have to work out the distance around the outside of our shape. Now remember, this distance from here to here, because it's the same as this distance, this will also be 50 meters. So that straight edge is 50 meters, this straight length is 50 meters. The part that we need to work out is the distance, the curved bit, which is around there, and the other curved bit, which is around here. Now, you might already know, because these circles are the same, and each of those is exactly half a circle, the red distance is going to be the same as the purple distance. So in this case, if you just work out one of them, then the other will be exactly the same. So I reckon you could probably have a go at this one on your own. So pause the video and see if you can actually work out the total distance around the outside of this shape. And when you've had a go, pause the video, restart the video and check your working. Okay, so pause the video now and have a go. Okay, I'm hoping you paused the video, and now welcome back. Let's go through and actually calculate the answer. So in this example, we knew that these two sides were 50. We have to work out this curve bit, which is the circumference of half of the circle. Okay, so once again we're going to use our circumference formula for a circle. So we know that the circumference of the circle is 2 times pi times r, so 2 pi times r, and in this case it's going to be 2 times 3.14, which is the value, our approximated value of pi, times r. In this case r is 20, so it's going to be times 20. So if we calculate that out, that equals 125.6 meters. So the circumference of the circle is 125.6. That's the circumference. That's the distance around one circle with a radius of 20 meters. That's that distance around there. The pink distance is only half of that. So the pink distance will be 125.6 divided by 2. But hang on a sec. This red bit is the same. And if we put the pink bit together with the red bit, both of these together will make up a full circle if we join them together. So in actual fact, this distance plus the red distance actually will add up to 125.6. So you may have already seen that. But anyway, each of those is a half, each of these sides is a half of 125.6, which is 62.8. And this one's going to be the same, 62.8. Remember, each of those is half of the circumference of the circle. So Add those together, and that will add up to 125 anyway, 125.6. Let's work out our circumference now. So starting at this point, it's going to be 50. It's going to be 50 plus 62.8 plus 50 again plus 62.8 again. So let's write that down and work it out. So the perimeter of this shape is going to equal 50 plus 62.8 plus 50 again plus 62.8 again. And if we add those up, that will equal 225.6 meters. 225.6 meters. So that's the total perimeter around this shape. Okay, our final example in this video is this one. Now we're going to do something similar, except we're going to do it a little bit differently. We're going to join these circles again like we did before. So I'm going to make a shape where we're going to join these two circles, and we'll get the right colour, blue. And I'm going to join them together like that. So far, just like the other example, but there's going to be something different. Watch this. This time, I'm going to erase this part. And I'm going to erase this part. So, in this example, we need to work out the distance around the outside of this shape. So, once again, let's put in some values and see how we go. This distance here, now I'm going to make this a little bit trickier. I'm going to make that distance, and it's going to be a big shape, I'm going to make this distance 2 kilometres. Big shape, isn't it? From there to there is 2 kilometres. I'm going to say that the distance from here to here is 1,000 meters. So the distance from there to there is 1,000 meters. From there to there is 2 kilometers. The question is, what is the perimeter around the outside of this shape? Now, if you feel confident, pause the video and see if you can have a go at solving it. I'll give you a clue though before you start. Remember, the units have to be consistent, okay? You must have the same units everywhere on the shape, so you might need to use your unit converting first. Pause the video now, have a go, and then come back when you're done. Okay, welcome back. Let's have a go at working out the perimeter of this shape. Okay, so once again, I should have put these little strokes in there, but these two sides, the two straight sides are the same. So if this side here is 2 kilometers, then this side's going to be 2 kilometers. So we need to work out the curved parts. And just to remind you once again, the perimeter of this shape will be the distance starting at any point. I'll start here. The distance around the perimeter will be the distance around the outside, so it's going to be that straight edge along there, and then I'm going to walk around here like this, like that, and then down this side. Oops, shouldn't have done that. around this side, and then around that curved part of the shape and back to where I started from. So that's going to be the perimeter of this shape. So an interesting point, in fact, is that you might be able to see whether I walk this way or whether I walk around that way, it's going to be the same distance. So whether it's a circle that goes inwards or a circle that goes out like that, it doesn't make any difference to the perimeter of the shape. And that's just a little interesting observation, I think. So we know these two. Let's work out the curved part here. Now, once again, that's half a circle. So if we work out the circumference of the full circle, that one there, and this one's going to be the same. These are the same circle because they've got the same diameter. This is 100, this is 1,000 metres. This must also be 1,000 metres. So these are the same circle. So if we work out the circumference of this circle and halve it, that will give us this curved bit. And if we work out the circumference of this full circle and halve it, that will give us this curved bit. So if we only do one, then that will be the answer for both. So let's do this one over here. So once again, the circumference of a full circle is 2 times pi times r, so 2 pi r. That's the circumference of the full circle, So it's going to be 2 times 3.14, which is our approximated value of pi, times the radius. Well, what's the radius? Well, remember, the radius is half of the diameter, so the radius is always measured from the centre. So from there to the edge, that's going to be a half of 1,000 metres. Oh, but hang on, 1,000 metres. That's in metres. But this is kilometres. So we need to have them the same. So we need to either convert the kilometres to metres or convert these metres to kilometres. Well, it's probably easier to convert metres to kilometres. And if you go back to our lesson on converting metric units or look at your notes, you'll know that to go from metres to kilometres, you divide by 1,000. And 1,000 divided by 1,000 is 1. So from there to there, that distance, the diameter of that circle is 1 kilometre, which means that the radius will be half a kilometre. So the radius of this circle is 0.5 of a kilometre. So the radius of the circle is 0.5 of a kilometre. So I'll write that 0.5 there. So let's now work it out. So it's going to be 2 times 3.14 times 0.5, and that equals 3.14. And that's pretty easy because 2 times 0.5 is 1, and 1 times 3.14 is 3.14. So the circumference of the full circle is 3.14 kilometres. 3.14 kilometres. That's the full circle. We only want half the circle, so we're going to divide that by 2. So that distance there, distance A, I'll call that distance there is distance A. So that distance A is going to be half of 3.14, so it's going to be 3.14 divided by 2, which is 1.57. 1.57, remember, we're operating in kilometres. So 1.57 kilometres. Now, if this distance is 1.57 kilometres, then this distance is also 1.57 kilometres because they're the same. So I'll call that B actually, and that's also 1.57 kilometres. So now we can work out our full distance, our full perimeter of the shape. Starting from here, it's going to be 2 kilometres plus this distance around here, which is 1.57, plus 2 again, plus 1.57 again. So if we write all that down now, the perimeter is equal to 2 kilometres plus 1.57 plus 2 again plus 1.57 again. Then our full perimeter is going to be 2 plus 2 is 4, and we know that 1.57 plus 1.57 adds up to 3.14. So it's going to be 4 plus 3.14, which equals 7.14 kilometres. So the perimeter around the outside of this shape is going to be 7.14 kilometres. And that's our final example for this video. Make sure you've copied the notes down. Make sure that you understand all the aspects of these videos. Feel free to go back and look at any of those videos again, or rewind this one to have a closer look. Then you may start on the following problems. And the problems I want you to do are as follows. I want you to have a go at exercise 12A of your textbook, exercise 12A, which is on page 381. I want you to do the following questions. I want you to do question 4, and then over the page I want you to do question 6, 7, 8, 9 and 10. So question 6, question 7, question 8, question 9 and question 10. And finally, the more advanced questions, which I'd like you all to do, or at least have a go at, is question 13 on page 383. And the ones I want you to do are A, B, C, D, F, G, H, and I. Those questions are on page 383. Feel free to go back and look at these videos again. Have a go at these questions. Just a final reminder. Remember that the success on tests that you do, it depends wholly on getting the work done. Get these problems done, do them in your book, check your answers, make sure you got them right, go back and look at the videos if you need help, ask me if you need help, and if you go through those processes, you will get a good mark on the next test. Good luck, and I'll get back to you soon. Goodbye.